Welcome, everyone. So, if you've ever stared at a circuit diagram and felt, I don't know, like you're trying to decode some ancient alien language, yeah, you're in exactly the right place today. We're going on a bit of an audio road trip through a seriously fascinating piece of engineering. The goal? We are going to completely demystify the TDA2822M audio amplifier circuit. We'll break down this whole intimidating blueprint step by step, making total sense of every wire, every resistor, and every capacitor. So let's just dive right into this.
To keep us on track, here's our quick roadmap for today. We're going to cover 1. Decoding the circuit diagram, 2. The input stage, 3. The TDA2822M amplifier brain, 4. The output stage, and 5. Powering the speakers.
Okay, so take a look at the complete blueprint we're working with today. I know, at first glance, it's just this maze of colored lines, tiny cylinders, strange symbols. It literally looks overwhelming. But I promise you, by the end of this explainer, you're going to be reading this schematic like a total pro. We're going to trace the audio's journey from the exact moment it enters the top of this diagram all the way down to when it blasts out of the speakers at the bottom.
Section 1. Decoding the circuit diagram. Finding the hidden symmetry.
You know, the absolute best secret to reading complex diagrams like this, it's to just take a step back. Look at the overall shape before you get bogged down in all those tiny details. We're going to use what I like to call the symmetry method. Because this is a stereo audio amplifier, it's handling two distinct channels of sound, right? The left channel and the right channel. So to create a perfectly balanced audio experience, the engineers actually designed this circuit so the left pathway is an exact, perfect mirror image of the right pathway.
Actually, if you just imagine drawing a line right down the middle of that central blue chip, you'll see exactly what I mean. Literally everything on the left side, the resistors, the capacitors, the wiring routes, it's completely duplicated on the right side. So the big takeaway here is this. If you can understand the components on the left, you automatically understand the components on the right. By just spotting that symmetry, we've basically cut the complexity of this entire explainer right in half. How cool is that?
Section 2. The input stage, tracing the audio signal. So we're going to start right at the very top of the diagram and follow the chronological journey of that raw, unamplified sound. Think of the audio signal kind of like water flowing through pipes. Step 1. Our signal enters at the points labeled input L and input R. Step 2. That electrical current travels down and interacts with the 10K resistors, and then Step 3. It flows toward the 100 microfarad capacitors before finally hitting our main amplifier chip.
Now, check out those red lines at the top. These are our positive input pathways. The raw sound comes in from input L and input R, and as that red line travels down, it actually forms a junction. One path reaches across those striped cylinders, those are the 10K resistors, and connects over to the thick black line on the outer edge, which is our common ground, or negative pathway. The other part of the red path keeps going down, flowing past those little black cylindrical components marked 100UF/16V. Basically, these 10K resistors set our input baseline, while those 100 microfarad capacitors, they act like bouncers at a club. They block any unwanted DC voltage and only let the pure AC audio signal pass through to the amplifier. They're working together right at the gate to condition and prep our delicate audio signal before the really heavy lifting begins.
Section 3. The TDA2822M amplifier brain, the core of the circuit.
All right, so our signal is fully prepped, and now it is ready to get boosted. Placed dead center in our diagram is the TDA2822M. Based strictly on its position here, this microchip is the central hub. It's the vital crossroads where our prepped left and right input signals converge, get a massive boost of electrical energy, and then exit out the other side headed straight for the speakers.
Look closely at this blue block branded with Toknomast. See how it has 8 tiny metallic legs, or pins? You can literally see our red input pathways feeding directly into the top pins of that chip. Inside that little blue rectangle is where all the complex amplification magic actually happens. Then take a look at the bottom 4 pins. Freshly amplified, way more powerful signals exit the bottom of the chip, and they're carried away by those bright blue lines and that looping red line. This chip is essentially the ultimate bridge between the quiet input and the loud output.
Section 4. The output stage, preparing for sound. Now, just because the signal is louder doesn't mean it's quite ready for your ears just yet. It really needs to be stabilized. As the amplified signal leaves the chip and heads downward, it runs into a whole new set of components. We can read these specific values right off the blueprint. First up, it hits massive 470 microfarad capacitors. These are way bigger than our input ones because they have to handle and smooth out a much more powerful amplified current.
Further down the line, it interacts with tiny 0.1 microfarad ceramic capacitors, and finally, 4.7 ohm resistors.
If you follow the bright blue lines exiting the bottom of the chip, the very first thing they hit are those big, gray, cylindrical 470 microfarad capacitors. The signal flows straight through them. But right after those big guys, the blue line branches out. While the main path keeps going straight down, a secondary path forks off to the side, flowing through the orange dish-shaped 0.1 microfarad capacitors, the ones marked 104, and down through the 4.7 ohm resistors before it connects back to the black ground line. This visual branching is super important. It shows exactly how the circuit filters and stabilizes that powerful new signal, making sure the audio stays balanced and totally clear without any of that annoying high-frequency noise.
Section 5. Powering the speakers. The final destination.
Okay, the signal has been input, prepped, amplified, and stabilized. Now, it's finally time to make some noise. After traveling all the way through those initial 10K resistors, the 100 microfarad capacitors, getting that huge boost by the chip, and being smoothed out by the massive 470 microfarad capacitors and branching networks, those electrical pulses finally have a physical job to do. They reach their mirrored destinations to generate true balanced stereo audio. Oh, and a quick pro tip here. If you're taking this blueprint to your workbench to actually start assembling and soldering, pay super close attention to the polarity markings on those big 470 microfarad electrolytic capacitors. Getting the positive and negative legs right is absolutely crucial for this to actually work.
Let's see how all this builds our final result. Right at the base of the circuit diagram, you see those brilliant blue lines? They're carrying the positive amplified signal and connecting directly into the positive terminals of the two Stockno-Master speaker units. Meanwhile, that thick black line that borders the entire circuit wraps all the way around to connect to the negative terminals of the speakers, completing the whole electrical circuit. Because we have that perfect symmetry we talked about at the very beginning, the left speaker and the right speaker receive identical, perfectly balanced treatment. And the result? Crisp, clean stereo sound.
And just like that, we have traced the entire blueprint. What started out looking like some intimidating alien schematic is actually a highly logical, perfectly symmetrical pathway. You now know exactly how to trace a signal from input through the resistors and capacitors right into the brain of the amplifier and out to the speakers. So my question to you is, now that you have the power to read this audio blueprint, what are you going to amplify first? Keep exploring, keep building, and I'll catch you on the next explainer.